Hello and welcome to this week's Alteryx challenge, challenge number 467. This week we will be estimating pi in Designer Desktop. This, just at the start of this, is a little bit concerning for me. I personally wasn't that interested in geometry when back in school, so I love algebra and all kinds of math and statistical things, but geometry itself I wasn't that interested in. But let's take a look, a bit more explanation of the challenge that we're going to be doing today. So, every year in the United States, March 14th, that's today, well no, that's tomorrow, at the time of recording, is Pi Day. Pi is a mathematical constant represented by the Greek letter pi. That's a ratio of a circle's circumference to its diameter, approximately equal to 3.14, 159, 314, 314. Okay, cool. So that's the relevance of this challenge. Among many methods available to estimate pi, one is called the Monte Carlo simulation. This method helps solve problems by simulating randomness. The Monte Carlo simulation for pi is a probabilistic method used to estimate its value using random sampling. Okay. So we have the data set for the challenge. It is randomly generated coordinates for x and y within a square. Scope's limited to 100 rows. We have 100 rows, randomly generated coordinates for our x and y distributed between 0 and 1. Our task for the challenge is to estimate pi and the percentage of variance from actual pi. To do so, we will need to combine x and y coordinates, determine whether a point is inside or outside of a circle, calculate the total number of simulations, calculate the total number of simulations inside the circle, and lastly, finally calculate the estimation of pi and the percentage of variance from actual pi. And if stuck, there's some hints in the workflow as well. And then we have, if we need more information, we can check out this article about using Monte Carlo and Excel to estimate pi. So that is definitely going to be a helpful resource, since just from this description alone, I don't understand much of what I'll need to do. So let's take a look in Alteryx, and we can check out the hints here. So we have the hints here. The equation of a circle with a radius of 1 and centered at the origin coordinate plane is x squared plus y squared equals 1. We have if x squared plus y squared is less than or equal to 1, then it's inside the circle, okay. And calculate the percentage of variance. With just those hints alone and what we saw in the description so far here, which is replicated here, this really isn't enough for me. So let's go back to that article. So I'll bring this down for now, and we can return to this article here and kind of scroll through and see if we can get a bit more context for what it is exactly that we will need to do here. So Monte Carlo, again, is used to solve problems by simulating randomness, often used for gambling, not super helpful. How to estimate pi with Monte Carlo, okay. Idea is that an area of a circle is a equals pi radius squared, I guess. So if the radius is 1 inch and the area of a circle is just pi, okay. Underlying logic. If the area of a square is 4 and the area of a circle is pi, then the ratio is the area of a circle divided by the area of a square. So pi divided by 4. And we can see this visually here. If we are to plot random points inside the square, count how many points are in the circle and how many points are in the square, then the ratio should be pi divided by 4. So if we multiply the ratio by 4, then we will have pi. That, I think, is all we really need to be able to solve this equation as far as Alteryx is concerned. I'd say that I still don't fully understand everything around pi, but I think just for the sake of completing this challenge, I don't fully need to. So let's take a look back in Alteryx. Okay, so let's start by just giving things a run and taking a look at our input data. So we just have our X and our Y's. We have 100 records for each. And take a look at our output. So we see that we're expecting 78 points inside that circle, 100 total simulations. So that's just the number of points that we have, and simulating whether those random points are within the circle or not. This will be the estimation of pi that we're expected to come with, and this will be the variance from the actual value of pi. Okay, so let's get started. The first thing we need to do is connect these x and y coordinates to each other, and the best way to do that is with the join tool. Of course, if you're combining data horizontally, join tool is definitely your go-to. So let's drag that in from this favorites tab, the most commonly used Alteryx tools, and drag our x and y to our input anchors. And it's not going to be like in SQL when you're joining. We're just going to join off of record position. We have 100 records and 100 records. There's no kind of key or anything field that is shared between them. We just want to kind of smack the two fields together. And let's give that a run. Now out of our J anchor here, we'll have all of our 100 records, and everything's next to each other. Nice. So now let's do that first part of the hint, and let's drag this container down a bit more so that we can have it in view as we're working on this challenge. So I guess the first thing we should do is try and see how many of these randomly generated points fall within our circle. So to do that, we're going to need x squared plus y squared. Okay, so to generate that formula, we're going to use the formula tool, and we're going to name this circle, and we can say pow of x, and we're going to raise that to a second, so x squared plus pow y 2. Okay, so we have x squared, y squared, turn that to a double. Okay, and that is fine for this portion. We can again give that a run, see what our result looks like. Okay, so we have a couple. We can see that most of these in our view here are below 1, but we do have that one that is greater than 1, so that's good. So now we can use that and say, check whether or not each point is inside or outside of the circle. So let's make a field for that. Let's say inside / outside, and let's say if circle is less than or equal to 1, then 1, else 0, and if. Okay, and let's make that an integer. Cool, so now we have whether or not a field is inside or out the circle or not. So we could count towards that 78 that we're expecting. Next, we need to see how many total simulations we're doing. And I think the most straightforward way to do that, or the easiest way and the least amount of tools, is to add in a record ID. And we don't have to add in any configuration to this, but we could just use a max of the record ID to see the total number of records we're working with here. And to count the number of points that we have inside the circle, we can sum this inside / outside field. So let's do that. We're going to sub that field and name this field inside. And what's this other one? Total simulations. And we're going to take a max of the record ID and name that total simulations. Okay, that's set up. Let's give that a run, see where we're at. Cool, perfect. So we have the 78 and 100, and we have the 78 and 100. Nice. Next, we'll need our estimation of pi, and I think that comes down to the ratio that we have here, so the 78 out of 100, and multiplying it by 4, like in the article that we just saw. So let's add in another formula tool and name this field estimation of pi. And we're going to do inside divided by outside, not outside, total simulations. And we're going to multiply that by 4. And we get that 3.12 that we were expecting. That's great. Don't know that much about geometry, but we've gotten most of the way there. We have 3 of the 4 different fields we need, and the last thing we need is the percent variance from actual pi. And we have that calculation very conveniently here in the hints section. So we can do that again in the same formula tool. We're going to add this column, so percent variance from actual pi. And that's just going to need to be a double. So what do we have? We have 100, and then we have our estimation of pi minus actual pi. So there's a formula for pi, so minus pi divided by pi. And we're going to need to add the multiplication symbol here. We can't just do 100 next to the parentheses in Alteryx, unfortunately. But that should get us most of the way there. Let's run this, give this a check. So we have negative 0.687316. And we have pretty much the same thing here. Ours is just to a few less decimal places, so it doesn't go all the way there. But that is it for the challenge number 467. Definitely a bit of a tough one. I was stunlocked there for a bit in the beginning when I first took a look at this challenge. Definitely not straightforward if you're not familiar with geometry and like geometry concepts and haven't touched it since high school, but definitely doable as an Alteryx challenge, and overall pretty straightforward and a simple thing that's being asked of you once you actually understand the question and what needs to be done. I hope you had fun with this challenge. Thanks for watching. Bye.